Polynomial graphs. Just a reminder on how the final is going to be graded. Each learning target is going to go in as a separate term score, similar to what we did with the units. So if you're wondering, hey, what do I have to get to end up with this? It's very tough to calculate because you're going to have like 4 or 5 different scores, one for each of these assessed sections. So folks, starting with polynomial graphs, the first thing that we need to know is the end behavior notation. So end behavior notation, the limit, no, not the limit. Can you guys be quiet? So as x goes towards negative infinity, and as x goes towards infinity. So it doesn't matter what the function looks like, you will always have this 2-part notation. Then the second part to the notation is, what is f of x approaching? Folks, I'm going to continue to be picky about this on the final, just like I was on the unit test. You cannot have equal signs in there. You have to be looking left and looking right. It's as x is approaching infinity, what is the function approaching? So end behavior notation is a big one. Next, the degree. The degree can be even or odd. And the degree tells us our end behavior. So if the degree is even, our end behavior goes in the same direction. So even, same direction. And odd, different directions. It does the disco dance. Next, the leading coefficient. The leading coefficient can be positive or negative. If it's positive, your right arrow goes up. And if it's negative, your right arrow goes down. So that combination of the degree with the sign of the leading coefficient will tell you the exact end behavior of the function. So sometimes we'll be given the graph and we can read our end behavior directly. Other times we'll be given the equation and we need to know the end behavior based on that degree and leading coefficient. Next, we've got real zeros. The zeros, and I'm just going to make this note right down here on this chart. The real zeros are the x-intercepts, the roots, the solutions. All of those terms are synonymous with each other. So normally for these ones, we would state it as x equals something. And then the y-intercept, remember, is 0 and a number. Now, on this section, with the maximum and minimum and relative max and relative min, next to these two, I want you to write absolute and absolute. Now, you can only have one absolute value, though you could have multiple points getting to that value. But relatives, there can be multiples of them. So let's just go ahead and do an example up here. If I have something like this, does this graph have any maximum high points? Yep. It's got a hilltop up here. So that's a max, a high point. These 2 points would be mins. But now we are going to classify what those points are. Is this maximum the absolute highest point that we can have? Nope, because the left arrow and the right arrow continue to go up. So it is still a high point, but it's just relatively a high point compared to the graph as a whole. Now, for this minimum, Is it a low point? Sure. Is it absolutely the lowest point our graph gets to? No. So this would be a relative min. What about this one? Absolute. Because that is the lowest point on our graph. Nowhere do we get anywhere lower than that. So the difference between the relative and the absolute is important. It was one of the more frequently missed things on the test just because a lot of students thought you could only have like one of each. You can have multiple relative values. You can have multiple max values and multiple min values. Let's see. For the equation in factored form, when you go to find this equation, you have to turn the x-intercepts into factors. Let's go ahead and sidebar over here. So to write the equations in factored form, we turn the x-intercepts into factors. And then we use the y-intercept to find the a value. So that's actually really similar to what we just did in the previous unit. So we had to try to use given points, the vertex and another point on the graph, to try to solve for that a value. Here we are trying to find our leading coefficient by using a known point, the y-intercept, and plugging into the factored forms. So I think I just want to go ahead and do I think we should just do one of these together. So folks, let's go ahead and look at this graph. And how many, actually we'll do this one. How many x-intercepts does this graph have? It has 1. That x-intercept is equal to 0. Now, when we go to write this in factored form, in addition to considering the root itself, we also have to consider multiplicity. So consider multiplicity. If it is even, it bounces, and if it's odd, it crosses. So going back up to that graph, what are we doing at that x-intercept of 0? That's a bounce. So that means our multiplicity is 2. So currently, what my equation looks like is y equals x is what gives me that x-intercept of 0 squared for the multiplicity. So this is my factor. That's my multiplicity. But what we don't know is the a value, the leading coefficient. We do know based on our graph that it is positive. So this is generally what our equation is looking like. So if we wanted to solve for the a value, what are we going to be plugging in for that y-intercept? So we can plug in 0, 0. 0, 0 is our y-intercept. So our y-intercept is 0, 0. So 0 equals a times 0 squared. And I guess we just get 0 equals 0, so not a super great problem to do. So a value is gone. It's kind of insignificant. So we're just going to say that y equals x squared. So let's go ahead. And I want you to try the one to the left. Find the x-intercepts and put those in factored form first. So it looks like we've got one root at x equals -3. Another one at x equals 1. And we're going to say close enough here that that one's at 4. So those are the roots. Now, if I wanted to turn those into factors, let's go ahead and show this work over here. This is number 2. This is number 1. So if I wanted to turn those roots back into factors, if x equals -3 is the root, what would be the factor that gives me that root? X plus 3. So y equals, we're going to have some a value, x plus 3. And then if x equals 1 is a root, what's the factor? X minus 1. If x equals 4 is the root, then x minus 4 is the factor. Now we consider multiplicity. How is my graph behaving at each of those roots? It's crossing at each of those. So we can go ahead and just use a multiplicity of 1. So now to find our a value, we're going to use our y-intercept. So I'm going to say that that y-intercept is about at 0, we'll say -1.2-ish. So -1.2-ish there. So that's what we are going to plug in for our x and for our y in this equation. So this is going to be x, this is going to be y. So 0 in for all the x's and -1.2 in for the y. So 0 plus 3, 3. 0 minus 1, -1. 0 minus 4, -4. So I have -1.2 equals a times 3 times -1 times -4. So 3 times -1 times -4 is -12. No, positive 12, my bad. So -1.2 equals 12a. Divide both sides by 12. And a is -1/10. -0.1, I prefer it as a fraction. So then our equation in factored form would be y equals -1/10, x plus 3, x minus 1, and x minus 4. So this a value is important, and you've got to be close. So if you said -1.3, that's probably fine, but you got to be fairly close to having that right a value. So I'll leave you guys to be able to finish the rest of these, but I want to go ahead and go through one of the ones down below with you guys. So on number 18, we want to sketch the graph of each polynomial. So we need to consider a lot of different things here. We need to first consider the x-intercepts and the y-intercept, the degree, and the leading coefficient. Now, what's kind of tricky about these problems is figuring out the degree. It's not in standard form, so our degree isn't just the highest power, it's the highest power we would get from each of the x's. So our degree of number 17 would be 3 and 1 or 4. So we add the multiplicities to get our degree. So the degree is 4. That means it is even degree. What's the sign of our leading coefficient?
Positive.
It's positive. 2 is our a value. So we got a positive LC. So with your arms, what does my end behavior look like? Up and up. So even degree, same direction. Positive leading coefficient means our right arrow is going up. So my graph is going to have arrows that look like that. So our end behavior needs to match. And I have to see some sort of work here to show that you didn't just use your calculator, you actually know the graph key features. So let's go ahead and see what else we know about this graph. We know the x-intercepts. So my x-intercept, one of them would be -1. Another one would be 5. Are we going to bounce or cross at those? Cross. So multiplicity is odd. So we will cross at both of those. So -1, 0. Boop. C for cross. 5, 0. C for cross. So we've got the degree, the leading coefficient, the x-intercepts, the y-intercepts. So actually, let's go ahead and put a little kind of thing around both of those and write end behavior, because that's what the degree and the leading coefficient lead you to, and that's what needs to match on your graph. Now for the y-intercept, we have our a value, which we didn't have up here, but what we need to do to find our y-intercept is plug in 0 to the equation to find the corresponding number that goes with it. So I'm going to plug 0 in for this x and this x, and then solve for y. So y equals 2 times 0 plus 1 cubed, 0 minus 5 to the first. And now we got to make sure that we're following PEMDAS. So exponents first, well, parentheses, then exponents. 0 plus 1 is 1. 1 cubed is 1. 0 minus 5 is -5. -5 to the first is -5. So then y equals -10. So my y-intercept is 0, -10. And that's a nice exact point. Now, is it always going to be a nice exact point? No. There was one test, we got like 1,225. So sometimes it's going to be a nice point. Sometimes it's not going to be an exact point, but we do still have to find it. So now we have enough information to sketch our graph. My end behavior arrows need to go up and up. So I'm going to draw that up. I'm going to cross, and come down and hit that y-intercept, and then I'm going to cross again. Is that exactly what our graph looks like? Nope, but that is a decent enough sketch based on our key features. And then on the next page, you're just calculating more of that from the graph. Do you guys want work time on that, or would you like to go through the Unit 4 stuff? Raise your hand if you want to do Unit 4 now. Raise your hand if you want to have some more time. All right, folks, let's go ahead and I think I'll just make a new video here.